we learn pre-envelope in this session. So these are the contents we have completed so far. In module 1, we studied the definition of Hilbert transform, time domain analysis of Hilbert transform, frequency domain analysis of Hilbert transform, some of the properties and proofs of Hilbert transform, and these problems on Hilbert transform solved. And these are some of the assignment problem you can solve it. So in this section we are now going to study pre-envelope. We learned here what is pre-envelope, how to extract the pre-envelope for positive frequency and for pre-envelope for negative frequency. We'll consider in this session. Pre-envelope is nothing but a complex signal in which imaginary part is Hilbert transform. So complex signal is represented by the form A plus JB, where A is real part and JB is the imaginary part. So the imaginary part is Hilbert transform of the real part. So let us consider a signal G of t. It is a low pass signal. Its frequency spectrum is as shown. So this signal is represented by equation 1, that is nothing but positive pre-envelope of signal G of t is given by G of t plus J G cap of t. Here G cap of t is nothing but Hilbert transform of the real signal. So we have analyzed frequency domain analysis of Hilbert transform. So we consider here Fourier transform exists. Therefore, we are going to write equation 1 by taking Fourier transform. Therefore, equation 1 can be written like this: G plus of f, that is nothing but G of f plus J G cap of f. Here this G cap of f is nothing but Hilbert transform of G of f. So we are now in frequency domain analysis of Hilbert transform. So from our previous discussion, what is G cap of f? That is Hilbert transform in frequency domain is nothing but minus J signum function into G of f. Now you substitute equation 3, that is this, wherever I am highlighting, in equation 2, that is here. So on simplifying, positive pre-envelope in frequency domain, that is given by G of f plus J into minus J signum function G of f. So simplify this, J into J is J square. So it is minus 1, minus 1 into minus is plus. So now equation is written like this: positive pre-envelope of the signal is given by G of f plus signum function into G of f. So here signum function is defined by equation 5. For the frequency greater than 0, it is having amplitude 1. For frequency less than 0, it is having minus 1 amplitude, and for f is equal to 0, 0 amplitude here. So substitute this equation 5 in equation 4 for this signum function. So you are multiplying amplitude of signum function with G of f. So based on that, we can write expression for positive pre-envelope, that is given by, for positive frequencies signum function is plus 1. Therefore G of f plus G of f, you will get 2 into G of f. Similarly, for f is equal to 0, signum function is 0. Anything multiplied by 0 is 0, but I have here f is equal to 0. Therefore I am going to write here G of 0. For f less than 0, signum function is having -1 magnitude, therefore g of f signum function is -1. Substitute here, minus of g of f yields 0. So you can write the frequency spectrum of positive pre-envelope of g of t as shown here, where negative component is absent here. So because of the symmetry of this spectrum, we can define pre-envelope for f less than 0 by g minus of t is equal to g of t minus j g cap of t. So what is minus stands for negative pre-envelope. So apply Fourier transform and you write this equation in frequency domain. It is g minus of f, that is equal to g of f minus j g cap of f. So we know that g cap of f is nothing but this is a Hilbert transform in frequency domain. Therefore substitute g cap of f, equation 3, where I am highlighting, into this equation and simplify. G minus of f, that is equal to g of f minus j. What is g cap of f? It is minus j signum function into g of f. Simplify. J into j is j square, it is -1. Minus into minus is plus, plus into minus is minus, signum function into g of f. So now you analyze what is negative pre-envelope for the frequency spectrum that is shown. So signum function is positive for frequency greater than 0, therefore g of f minus g of f will be 0. Similarly, for f is equal to 0, I am going to write here g of 0, and for f less than 0, here signum function takes the value -1, therefore g of f minus g of f is nothing but 2g of f here. So write the frequency spectrum for g minus of f, that is g minus of f here, that is given by here as shown. So this is nothing but the pre-envelope concept that we are going to understand based on the Hilbert transform. So we are going to extend our knowledge in separation of the band pass signal into a low pass signal in the next coming lecture series.